Okay. So we're gonna go over 44. 44. I think we need to have a Zumbi uprising, in my opinion. You guys need to make it happen.
Too much work.
Go and demand that mornings are abolished.
Yeah.
No more mornings.
I was worried as long as it's not going to go to school someday.
4-day school week.
A lot of good.
I feel like there would be a lot of support for that.
I like.
With Fridays off.
No school week.
I'd rather have Wednesdays off, actually.
They're kind of divided up, that'd make it nice.
2 days, 2 days. Okay, so the second to last thing we got to cover about momentum. And this is still more combining like momentum with the idea of energy. So if you know about momentum and energy, you can analyze a system more biglier than you can if you just know about one of the two. So what am I talking about? 44 is like, hey, we've got a block traveling along. Block A is what? How heavy is block A?
10 kilograms.
10 kilograms. Good. He is going to bump into block B, who is initially at rest. So block A is traveling 8 meters per second. This guy's at rest, and he is only 6 kilograms. Okay, so we know what's going to happen. There's going to be a collision, and then at least one of these blocks is going to slide up the roof, right? Now, it does tell us that they make a perfectly inelastic collision. So what does that mean, it's a perfectly inelastic collision?
No energy on reserve.
Oh,
The minimum.
Oh,
Yeah.
Okay. They stick together. So that's the key to solving the question, is understanding that perfectly inelastic collision is kind of fancy way of saying they're gonna be traveling with the same speed after they collide. They're gonna stick together. Does that make sense? Oh. Hey, Henry shoveled a driveway this morning. That's all I needed to get through the day. Just know that Henry shoveled the driveway.
Good job.
How big of a driveway was it?
In Whitefish.
Whitefish. Was it by hand?
Yes,
All by hand.
yes. And it's like it would comfortably fit 4 cars. So like
That's a good amount of shoveling, yeah. And it's probably heavy snow, wasn't it?
it was horrible. Awful.
However, Henry's the most joyful and energetic
Slush
one.
hour. Is it like Hoover scoopers, like, or is it like
what
the,
the hell are you talking
it's the snow shovel? Is it like the big ones that you like shovel horse things out?
Whichever one is the
It's
biggest
just
one
like
that I have.
A normal snow shovel. With
Okay.
a metal edge so that
Yeah.
you can scrape tracks.
Oh, you gotta have the metal end.
about?
If you really want to learn the value of hard work, you got to use like a gardening spade. Then you'll appreciate
A plastic spoon.
it. Yeah. Okay, so what we're gonna do is we're gonna figure out basically how fast. This is kind of the moment in time we're looking at. Is how fast were the blocks moving together when they were right here? So I'm just gonna call this. There's only one V I care about, so I can just use the letter V to say how fast were they moving after they stuck together. Does that make sense? What am I going to do with that information once I know how fast they were moving?
Figure out.
MGA.
Yeah.
Use a 1/2 mv squared equals mgh type argument to figure out how high it's going to go. So it's actually a pretty easy question once you know the sort of the plan. Let's do the momentum calculation though. Okay. By the way, maybe this is misleading. The momentum calculation doesn't really have anything to do with this. It's purely about this moment. It's the collision before it, well, it's still on flat ground, right? So the momentum calculation goes, initial momentum must equal the final momentum for the system. So how much momentum do we have at the beginning? 80, so 10 times 8 plus 6 times 0. And after the collision, this is before the collision. After the collision, we have
16B.
yeah, so they're going to be basically moving together, so we can just go 16 total mass times V. What is 80 divided by 16? 5. Great. All right, does that answer make sense? That, it wasn't going 8 meters per second. After the collision, it's going slower. Good morning, Mr. Thompson.
Hey, is Winslow here?
No, it's not. Okay, so now we just kind of shift gears in our head like, well, we know how fast this block is going, right? So I can go, now let's talk about this first one was momentum. Now we got to talk about energy. So to figure out how high they go, we use conservation of energy. So you go, well, what's the mass of the block? 16, right? So you're gonna go 1/2 times 16 times v squared. So there's your 1/2 mv squared. And set that equal to the potential energy here, which is mh. And we just got to solve for one variable, so that's nice. Neato burrito? Yeah. Okay, so what did we get for this one? What's the answer here? What'd you get? 1.28 watts. Meters. Okay.
I thought you said like
Watts.
I was like, what?
So, now that I'm thinking about this, we'll just have, I'm going to cover the last page here. So I know there's a few on here that I think you'll be able to figure them out, but if you get stuck, we can look at them tomorrow or Wednesday or something. But I want to go over this last little page. It's only 4 questions. It's just supposed to show you a very simple idea. And I got a video to show you. I guess I'll try to move this. No, it's not going to show up. I'll show the video at the end after I'll post the video in like the description of the video, I guess. So anyway, here's the idea. The big tragedy is there used to be this video that I used to find from this like fantasy TV show where this like barbarian, they break into this like looks like some sort of like medieval looking room, and he throws an axe at this guy, and the axe just like travels through the air like without spinning at all. So it's really hilarious. But now, since there's all these like axe throwing businesses, when you try to find the video, you're just drowned in videos of like lol, axe fail, like some guy like throwing an axe into the ground at one of those. Anyway, so I couldn't find it, sadly. But anyway, so when you throw something, so here I'll take this marker. When you throw something, right? What kind of path does it take?
Parabolic.
Right? You go, oh, it takes a parabolic path, right? But then you might go, wait a second. I watched that marker And it didn't seem parabolic to me. Right? What if you watched this marker fly through the air, right? You might go, well, I watched the cap of the marker, right? So here's the marker. Close enough? Okay, there's the marker. And I watched it, and the cap took some sort of weird spinny trajectory like this. So how do you reconcile that with our knowledge that, or at least we think, I mean, shouldn't things follow parabolic paths? Would anyone have an idea based on what we've been studying? Yes? Yes.
Center of mass follows the parabolic.
That's perfect. Yes, perfect explanation.
That's right,
That's
'cause
what I think.
look when the rocket, like if the rocket blows up or whatever, like all the pieces are still gonna be.
Yeah.
Yep. So Colin had a great explanation. Hopefully you heard it. It was there's two things going on. One, if you track the center of mass, so say the center of mass is right here, the center of mass does follow a nice parabolic trajectory. And then remember how we were talking about like traveling along a center of mass frame for a system? If you did that, if you traveled along this with the pen, you would just view it as the pen spinning around its center of mass. Does that make sense? Because if you were traveling along this parabola with the pen, you wouldn't really think the pen was moving. You would just see it as spinning. Does that make sense? So there you go. That's the core idea right there. Is that when something is a projectile, right? If it's a little point mass, like a little sphere, it's just going to follow a nice parabolic trajectory. But if it's like a hammer or an axe or a pen or really anything that's not a little sphere, its center of mass will be the thing following the parabolic trajectory. So we can just go over these questions, just kind of answer them conceptually, I guess. None of these require any calculation. So, like for example, let's just skip down to 50 real quick. So I think 50 is maybe the one that 49 I pretty much just talked about. So you can try your best to draw a picture. Keeping in mind for an axe, if the head of the axe is made of like steel and the handle is made of wood, where's the center of mass for an axe? Very close to the head of the axe, right? And so when this thing spins, can you imagine the bottom of the handle is going to follow a much bigger curly Q shape than the head of the axe is going to be spinning around. So you can visualize that center of mass trajectory. So like if I had made, if the cap of the pen had been made out of lead or something, then the cap might have followed this really small trajectory as it spun around, whereas the bottom of the would have a bigger curly Qs. But anyway, any basketball fans? You might have seen. I know Aaron likes basketball, or he plays basketball. Do you like to watch basketball?
Not the NBA, but I like college.
You get this more in the NBA, but like how sometimes a player will like appear to kind of float, like defy gravity. It's not just basketball where you'll see this. You'll see an athlete kind of jump, and it kind of creates this illusion of like, wow, they look like they're kind of just like gliding in a straight line through the air. Like, so what's happening there? So like at 50, Bob says, I've heard that projectiles follow parabolic paths, but I watch a lot of pro basketball and in a lot of big dunks, it doesn't really seem like they're following parabolic paths. Like if you watch the ball, it often looks like it's traveling in a flat line through the air until it gets dunked. How is that possible? So how's that possible? Anyone got enough? Who could explain it to Bob?
Is it just like a shallow parabola?
There could be that, yeah. If you run with a lot of speed and then you jump, your parabola, it could be kind of flat anyway.
It's the old
It's
Michael
like-
Jordan.
Since
Yeah.
it would be like flat and long, I guess it gets basically stopped at the hoop before it really should shows its entire arc.
Oh.
Well, let's
like
back up.
the-
This, so let's say this is the basketball's, sorry, well, I don't want to give away the answer, but here's the hoop, right? Let's say the hoop's here. This is maybe a hint to the answer. There's the hoop. This is the path of what?
The player.
Center of mass.
The center of mass, yeah. The center of mass of the player ball system. Now, I know the ball is very light compared to the player, so, but this is the center of mass, but you can contort your body in midair, right? So once you're in midair, you can say stretch your arm out, or say stretch your legs out, or there's a number of ways you could change the configuration of your body, right? That might create the illusion of, so a lot of times you'll watch their feet, like on a Jordan, the famous Jordan dunk, you like watch his feet, his feet are just like floating. What's happening there is he's jumping, and yeah, like, so maybe in the beginning, right, his center of mass is probably somewhere in his torso, right? And it'll pretty much be that way, but if his legs are initially like bent, and then he tends to stretch the legs out. When you stretch your legs out, that actually drops your center of mass. Does that make sense?
Yeah.
So like if you were, this is an exaggeration, but this person's center of mass might be like way up at their chest, upper chest, but then if they say make their legs straight and then like lower one of their arms, for example, that would drop their center of mass. But keep in mind that whole time, their center of mass is following that trajectory. So if you're watching, say, the ball, and they're changing the relative position of the ball as they're moving, that could create an illusion of. Does that make sense? So the shortest answer is that. So yes, Bob, that may be true that the ball itself is not following the parabola. That's certainly true. It doesn't defy any physics. Or the feet may be following the center. Following a non-parabolic path, but the center of mass of the player ball system is what's following the parabolic path. So, okay. Anyway, I hope those make sense. I was going to show you 2 little videos here, and for all the millions of Twitch fans, I'll try to put a link. Link for merch in bio. Buy my merch.
You made merch, I'd buy it.
Oh, okay, sweet. We'll make what's it called? Back it up. What was Zach talking about? Back up the